Welcome back. In this video, we're gonna solve this question from Berkeley Math Tournament. I think it's 2022 because of this 2022. I think it's 2022. Okay, here we wanna find the derivative of this function at 0, but the derivative of order 2022. Okay, we can use some because we have this sign here, we can use some complex analysis to find this one here. Okay, we'll make it quick and easy. We're gonna see why. So one key idea is to write this one x sine x in terms of complex variables. So here we have e to x times e to ix. We know that's e to x cosine x plus I sine x. Okay, we can write it again as ex cosine x plus I ex sine x. Okay, therefore this one we can write it using the rules of the exponent in complex analysis. So we can see that this one is 1 plus ix. And the key is that we note that the real or the imaginary part of e to 1 plus ix is e to x sine x. So this is the imaginary part, this is the real part. So we can differentiate this one. It's the same as we are differentiating this one. Okay, one key idea is that if we treat this one, let's call it f of x as e to 1 plus ix. So the derivative of this one of order n is fn. That means the derivative of order n of this function is 1 plus I to the power n e to 1 plus ix. Okay, we can prove it by induction. Or we can just see from this one here that e to alpha x, if you differentiate this one time, you get alpha e to alpha x. If you differentiate twice, you're going to get alpha squared e alpha x. And you see that this order of the derivative is the order of the power of this 1 plus I. Okay? Therefore, we're going to evaluate this one as 0. Okay? So this derivative we evaluate at 0, and we take the imaginary part. Okay, so when we have the number that we need, which is 2022, this gives that f 2022 of x is 1 plus I 2022 e to 1 plus I x. Okay, so here if we want to have the 0, okay, if we plug the 0 here, we see that f 2022, the derivative of order 2022 at 0 is 1 plus I 2022, but e to 1 plus I times 0 is just 1. Okay, therefore, so here this one is just the derivative of order 2022 with respect to x of e to x sine x, okay, evaluated at 0. So it's the imaginary part of this one. So we need to have the imaginary of 1 plus I 2022. Okay, so but here we see that 1 plus I 2022 is 1 plus I to the power 2, and after that to the power 10, 11. Okay, we can compute this one, 1 plus I squared as 1 plus 2i minus 1, which is 2i. Therefore, this is 2i to the power 10, 11. Okay, we can take the 2 outside. We're going to have 2 to 10, 11, and I to the power 10, 11. So we can simplify this I to the power 10, 11 as we can I to the power 10, 11 is I to the power 1 times I to the power 10, 10. Okay, so I to the power 10, 10. Okay, let me write here. I to the power 10, 10 is I squared to the power 505. And what's I squared? Minus 1. And minus 1 to an odd power is always minus 1. So therefore, we have this one. I to the power 10, 11 is just minus I. And therefore, this number is just minus I 2 to the power 10, 11. And therefore, the imaginary part is minus 2000, minus 2 to the power 10, 11. This is the value that we need. So the value of the derivative, okay, here. So this is just minus 2 to the power 10, 11. Okay, we had to explain all the steps for those of you who don't know the complex computations. So this is the value of this derivative. Okay, is there any other way to do this one? Yes, there is a longer way, but this is the quickest way, I believe. Using complex analysis, you can do it quickly. This is we can use the derivative of the product, the Leibniz rule, but since this one here, it won't be simplified because we know that the derivative of order k of the sine is just the sine of x plus k pi over 2. You can prove this one by induction and use it here. Okay, but the computation will be longer. So this is a quick way. Okay, so the value is minus 2 to the power 10, 11.